Evening class. Today we're going to talk about titration of known molarity to determine the molarity of an unknown base, or vice versa. Now, what we first are going to do is pour one of our unknown solutions into an evaporating dish. This solution is a sodium hydroxide solution, and we're going to pour 2 milliliters of it into an evaporating dish. And then we're going to put phenolphthalein into the dish. Now, phenolphthalein is something called an indicator because it indicates whether or not a solution is acidic or basic. It indicates this property by turning clear when in acid and turning a deep pink when in a base. We're going to pour drop after drop of hydrochloric acid solution of known molarity, and we know that the molarity of this hydrochloric acid solution is 1. Drop it drop by drop into the sodium hydroxide is that it took 36 drops in order to turn the solution clear. It turns out that 36 drops equals to be about 1.2 ml. So now we have enough information to calculate the molarity of the unknown sodium hydroxide solution. And we're going to use the formula, and this was going to be on the screen, hopefully. Acid volume, so the volume of the acid times acid molarity equals base volume times base molarity. Using that property, we're going to be able to determine what the molarity of the base is, because we know that's when it turns after 1.2 milliliters of acid volume. So let's plug in our equation, and that's 1.2 mLs times 1 molarity, because we have 1.2 mLs of volume of acid solution of no molarity, times 1 molar, because it's times acid molarity in our equation, equals the 2 milliliters of base, which we have in there, times the molarity of the base. Now, we don't know the molarity of the base, so we're going to make the molarity of the base equal to X. So our full equation is going to be 1.2 ml times 1 capital M, meaning molarity, equals 2 ml times X. And it solves to be X equals 0.6 m. So we've discovered that the molarity of this unknown solution of sodium hydroxide is 0.6 m, meaning there are 0.6 moles per liter. So we have successfully determined the molarity of this unknown solution. So we're going to repeat this experiment for the 3 other bases, and the 4. Alright, never mind, let's cut that out. So we're going to repeat this experiment for the 3 other bases, and also for the other acids. But when we do it for the acids, everything's going to be the same except for a couple aspects. The phenolphthalein is going to start out clear, and as we pour sodium hydroxide into the acid, it's going to turn pink. From pink to clear, it's going to turn from clear to pink. Great. So after we ran through the experiment, we got the results that the 4 unknown solutions A, B, C, and D had molarities of 0.6 m, 0.4 m, 1 m, and 2 m respectively, and the 4 acids had, A, B, C, D had the molarities of 1.3 m, 0.6 m, 0.1 m, 0.1 m, and 0.8 m respectively. So what we have just done is used a solution of known molarity to calculate the molarity of an unknown solution using phenolphthalein as an indicator to indicate whether or not it is acidic. And we had a lot of fun. It was pretty fun, yeah, if you ask me. So Thanks for listening. Bye. No, that's a weird bye. That's a weird bye. To cut that out.